Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
2 weeks after my 19th birth date in Nigeria, I received a scholarship letter from Monmouth, Oregon, United States, that was dated September 10, 1973. That scholarship letter opened the door for me to enter into the United States. I received that scholarship not because I was good looking, but because I was good in mathematics and physics. That first and subsequent scholarships were renewed for 16 years and renewed across 6 American universities. In February 1991, the last of those 6 universities did something it never did before in its 2-century history. That university devoted a special issue of its flagship quarterly publication to a supercomputer scientist named Philip Emeagwali that it described as one of the world's smartest humans. The essence of that story spread like wildfire and is repeated decades later and across social media and whenever the subject of conversation is about the world's smartest persons. When I was 5 years old, back in January 1960, I enrolled in St. Patrick's Primary School, Sapele, Western Region, Nigeria. For the 5-year-old, his frontier of mathematical knowledge is the arithmetical times table that was unknown to him, but was known to mathematicians that lived 5,000 years earlier and along the valley of the River Nile of Africa. When I was 9 years old, back in January 1964, I enrolled in St. John's Primary School, Abo, Midwest Region, Nigeria. For the 9-year-old, his frontier of mathematical knowledge was the quadratic equation of algebra. The quadratic equation taught in high school was derived over the past 4,000 years, dating back to North Africa. Growing up in the 1960s post-colonial Africa, I had no sense of the history of mathematical inventions. I had no sense of who discovered the times table. I had no sense of who invented the quadratic equation. I had no idea that 30 years later, I would be in major US newspapers for inventing 9 partial differential equations of calculus and for inventing the as many companion finite difference equations of algebra that in turn approximates those partial differential equations. As a small boy, growing up in the early years of post-colonial Nigeria, I presumed that the times table in my arithmetic textbook and the quadratic equation in my algebra textbook had been known to textbook authors since time immemorial. I presumed that Adam and Eve studied the quadratic equation in their Garden of Eden. As a teenager in Nigeria, my greatest epiphany was that the arithmetical times table and the algebraic quadratic equation did not spontaneously create themselves. As I grew, I learned that the partial differential equation of calculus were not known known to our distant ancestors that hunted wildlife and gathered fruits. I learned that calculus was invented 3 centuries and 3 decades ago, and that the partial differential equation was invented merely a century and a half ago. As a small boy growing up in Nigeria, I had no sense that the earth was round. I had no sense that the earth is merely 4.6 billion years old. I had no sense that our universe is 13.8 billion years old. I had no sense that humans had merely roamed the earth for only 100,000 years. As a small boy in Nigeria, I thought that arithmetical and algebraic knowledge came fossilized with the dinosaurs, that we are the monstrous lizards that roamed the earth and did so from 252 million years ago to 66 million years ago. The contributions to science of scientists born in Africa will increase during the 21st century. And the reason is that by the mid-21st century, 1 in 2 children will be born in Africa. My country of birth, Nigeria, has 200 million people and is more than half the population of the United States, and could be as populous as the United States, or 400 million people by the year 2050. In the year 2050, Africa could de facto become the face of humanity. For that reason, the African child born today will become the custodian of tomorrow's technology. Nigeria needs more scientists than the United States. If Africa has 60% of the world's arable land, why then is Africa importing food from Europe? The answer is that Africa lacks the knowledge that pertains to science and technology. We have African inventors, but no African inventions. Is there a school subject called African science? Is there an African quadratic equation? Is there an African medicine or African magic? Or is there an African law of physics or an African supercomputer? Why is Philip Emeagwali famous? Why is Philip Emeagwali important to the world of computers? In 1989, I was in the news as the African supercomputer genius that won top US prize. I was in the news because I discovered how to produce the world's fastest supercomputers and how to manufacture them from a large ensemble of the world's slowest processors that were identical to each other, that were equal distances apart from each other, and that shared nothing between each other. That discovery from my parallel supercomputing experiment of July 4, 1989 is the foundation of the modern supercomputer that now computes and communicates in parallel. That discovery of practical parallel supercomputing added a new pillar for the never-ending quest for faster and faster supercomputers. I discovered practical parallel supercomputing as the new technology that will underpin future computers and supercomputers. To stand at the farthest frontier of supercomputer knowledge was a surreal feeling that gave me goosebumps. On my eureka moment of 8:15 in the morning of the 4th of July 1989 in Los Alamos, New Mexico, United States, I saw for the first time a never before seen supercomputer. That virtual supercomputer was beyond the computer and is not a computer per se. It is a new internet de facto. Why is Philip Emeagwali important to the world of mathematics? Studying mathematics and understanding the partial differential equation will not make the cover story of the top mathematics publications. I invented a new system of partial differential equations that was the cover story of the May 1990 issue of the Siam News, the top publication in research mathematics. Abstract calculus and large-scale algebra were at the mathematical physics core of my supercomputer invention. My contribution to modern mathematical knowledge and extreme-scale computational physics is this. I constructed algebraic algorithms that I used to derive a new system of finite difference equations of algebra that approximated at finite places my new partial differential equations of calculus that was defined at infinite places and therefore required infinite calculations to solve its associated initial boundary value problem exactly. What made the news headlines was that I, Philip Emeagwali, discovered how to crank up my computations and email communications and do so by 16 levels and by computing and communicating their answers across a new internet and doing so simultaneously within 2 raised to power 16 or 64 binary thousand central processing units or within as many computers. Since 1989, I gave lectures in which I explained the details of how I discovered the world's fastest supercomputer. Those lectures were videotaped and posted at emeagwali.com. Please allow me to present a 1-minute version of the new mathematical core of my 200-hour lecture series on my contributions to the development of the computer. In the 1980s, I invented complex email communication primitives, each consisting of a pair of 5 subject line and 3 subject line emails. Each email was addressed to 65,536 or 2 raised to power 16, 16-bit long email addresses. Each email contained a computational fluid dynamics code that each solves an initial boundary value problem of calculus and their initial and boundary conditions. Each email was simultaneously delivered at ferocious speeds and synchronously delivered across some of my 16 times 2 raised to power 16 or 1,048,576 bidirectional email wires. Those email wires had a 1 edge to 1 wire correspondence to the as many bidirectional edges of the cube in an imaginary 16-dimensional universe. The end result was that I discovered how 65,536 central processing units can emulate a giant seamless cohesive central processing unit that is 65,536 times more powerful than one original CPU. I visualized setting up all 65,536 initial boundary value problems that mathematically define the grand challenge problem and setting them up like ducks in a shooting gallery. My quest was to discover how to topple those ducks over and like a domino. Because I did not invent practical parallel processing in prose, some knowledge of that technology is lost as I translated my new knowledge into a scientific report that is further reduced to a school inventor report of the 12-year-old. In retrospect, the laws of motion of physics were discovered 3 centuries and 3 decades ago. The technique of calculus was also invented 3 centuries and 3 decades ago. The partial differential equation of calculus was invented a century and a half ago. The partial differential equation is the recurring decimal in computational physics, such as extreme scale, high fidelity petroleum reservoir simulation that is used to extract crude oil and natural gas, and such as long-term general circulation modeling that is used to predict global warming. The super-fast supercomputer is used to solve the world's grand challenge problems, such as foreseeing otherwise unforeseeable climate changes. The high-performance supercomputer is used to increase the pace of scientific discovery and technological invention. The massively parallel supercomputer is used to increase economic growth and to create new mathematics. My contribution to super-fast mathematical computations is the reason my name, Philip Emeagwali, and my photo appears in the mathematics textbooks of some 12-year-olds. Students that learn about the parallel supercomputer are more likely to choose a career in computer science. My contribution to super-fast mathematical computations was the reason my photograph and the description of my new partial differential equations graced the cover of the May 1990 issue of the top publication in the world of mathematics, namely the mathematician's newspaper called Siam News. The supercomputers of the past sequentially process the floating point arithmetical operations that must be executed to solve grand challenge problems arising in STEM fields. In contrast, the supercomputers of today parallel processes the toughest problems by solving 1,000,000 problems at once. Harnessing an ensemble of 1,000,000 electronic processors and using it to simultaneously and cooperatively solve a grand challenge problem is mathematically similar to also using an ensemble of 1,000,000 human computers and using it to tackle the same grand challenge problem. Parallel processing was science fiction when it was first theorized back on February 1, 1922. Simultaneously solving 64,000 initial boundary value problems of mathematical physics was theorized in the book titled Weather Prediction by Numerical Process. The science fiction and parallel process solution of that grand challenge problem of 1922 was defined as 64,000 human computers parallel processing the weather for the whole globe. That was the science fiction precursor to the general circulation parallel processed modeling of today that is used to foresee otherwise unforeseeable global warming. My parallel supercomputer quest that began on June 20, 1974 in Corvallis, Oregon, United States, and ended on the 4th of July, 1989 in Los Alamos, New Mexico, United States, was to make that science fiction of 1922 a reality. I was in the news headlines when I made that parallel supercomputing discovery, and did so 67 years later. The big jump in the speed of the supercomputer of today came from my discovery of parallel supercomputing that occurred on the 4th of July, 1989. Parallel supercomputing, or doing many things at once, is the vital technology that underpins the world's fastest computers. To invent the parallel supercomputer was like gazing across the centuries, gazing across the millennia, and searching for our post-human descendants of a million. I once dreamt that in 65,000 years, a super intelligent 5-year-old will be a parallel processed cyborg, a half human, a half machine. But yet that post-human cyborg had no sense of the history of who invented his or her parallel processed self. If the history of science repeats itself, the names of today's inventors will be lost in the mist of time. The quest for how to massively parallel process across an ensemble of 1 million processors was in the realm of science fiction for 7 decades. Parallel supercomputing was the unorthodox and staggering supercomputer theory that changed the way we look at the modern computer. Before practical parallel supercomputing was discovered, we looked at the core essence of the supercomputer as an isolated processor that is not a member of an ensemble of processors, but as perhaps a main node on a new internet that is a planetary super-sized supercomputer hopeful. After I discovered practical parallel supercomputing, I looked at the fastest supercomputer of tomorrow to be a global network of processors and to be a new internet that will be a planetary-sized supercomputer, hopeful, that encircled the Earth. I was in the news in 1989 because the parallel supercomputer that I discovered was a game changer that changed the game of supercomputing. The bird sings the same song as its ma and pa. Human progress occurs when we sing a better song than our ma and pa. I'm Philip Emeagwali. I've fully described my contributions to the development of the modern supercomputer that is the world's fastest computer. And I've described my contributions at emeagwali.com. I, an African inventor, invented practical parallel supercomputing that is used to solve real-world problems, and that is the technology that underpins everyday supercomputer. The Philip Emeagwali computer is a human invention that is my contribution to human knowledge, but that is not an African invention per se. Thank you.
Insightful and brilliant lecture. Insightful and brilliant lecture.